Hello dear viewers, welcome to my tutorial video. In this session I am going to show you how you can create a SCADA project for Siemens S7-1200 series PID Compact program using TIA Portal software. And using this PID Compact program with SCADA system, you can perform Wincc SCADA-based PID control for a real-time temperature process. In this video, you will go through the process of hardware configuration and communication setup for simatic PC station, management of tags, as well as designing HMI screen in the environment of Wincc Runtime Advance. Finally, we will perform a real-time temperature control of air heating system using this Wincc SCADA interface. In the previous video, the process for creating PID Compact program and using this PID program, a real-time temperature process control have been shown. In this video, we are going to create Wincc SCADA project for this PID Compact program using TIA Portal software. For creating SCADA, at first we have to add simatic PC station. From the project tree, navigate to Menu for Add New Device and double-click on it. The window for Add New Device has been opened. Click on the menu for PC System to get the list of PC stations on the right side. Expand the menu for Simatic HMI application. Here you will find the three types of simatic PC stations. Select and add the PC station Wincc Runtime Advance in this project. The PC station Wincc Runtime Advance has been added in this project that has been appeared as PC System 1 in the project tree. We are now in the device configuration window for simatic PC station. From the menu tree for Hardware Catalog, expand the tab for Communication Modules. Under the tab for Communication Modules, expand the menu for IE General and drag and drop this module to the slot of simatic PC station. Now we are in the Device Configuration window under the Device View tab. Switch to the tab for Network View. Here you will find all the devices that have been added in this project. In this window, we have to establish a network connection between the PLC and simatic PC station. Make a network connection between the S7-1200 PLC and simatic PC station. Now a network connection has been established between the PLC and simatic PC station, and these have been registered into the same network. Click on the icon for Show Address Labels in the menu bar for Device Configuration window. Here you will find the IP address for PLC and PC station that have been set by default in this project. Check if your PLC actual IP address matches with the IP address shown in this project. Note that IP address for these devices must be set properly, otherwise the PC station will not communicate with the S7-1200 PLC. Now for creating HMI screen, go for tab Add New Screen in the project tree and double-click on it. A blank new screen has been appeared on the right side. Here we have to add necessary objects for PID operational and tuning parameters. First, we are going to add numeric field to access and show the parameter process value, which is outlet air temperature of heating chamber. Go to Toolbox palette on the right side and add an I/O field from Element Object folder. Now add a text field from the Basic Objects folder and resize this text field object with a name to give it a suitable look. Move to the I/O field object and resize it with appropriate font size. Now we have to link the tag for this I/O field. In the Inspector window under the Properties menu, go for General tab and click a selection field for Process Value I/O tag. The window for tag selection has been appeared. For handling PID parameters, a data block has been created in the list of PLC program, so we can select tag for this I/O field from this data block. To find the data block, expand the tab for Program block. The data block for PID program has been appeared. Click on the tab for Data block PID data. On the right side, you will find all the tags or variables for PID parameters. Select the tag Air Temp for Process Value field. Adjust the format pattern for this I/O field object. One I/O field object for PID parameter process value has been created and linked with the tag for monitoring process value. Now for creating I/O field object for PID parameter set value, just copy and paste this existing I/O field and link the tag set value from the data block. Similarly, create I/O field object for the PID parameter manipulated value. Create I/O field object for controller output in manual mode, which has been created as manual value in the data block. When the controller will be run in the automatic mode, the I/O field for manual value has no interaction with the operator, so we want to make this field invisible when the controller runs in the manual mode. So go to Animation tab and add visibility animation for this field object. Similarly, add visibility animation to the I/O field for controller manipulated value or output value in the automatic mode. This will make this field invisible when the controller runs in the manual mode. Merge these two fields so that only one field is visible in controller automatic or controller manual mode. Now create a button for switching controller mode between automatic and manual and link a tag for this button from the data block. Create another button for turning the controller in enable or disable mode. Now, to show the active status for controller mode button and controller enable button, we have to add two text editor objects for these two buttons. From the project tree, navigate to Tab for Text and Graphic List and double-click on it. The window for Text and Graphics List has opened. In this window, create two variables with their respective dynamic text. Switch back to Window for HMI screen. Now, link the dynamic text variable for these two buttons.
Now add I/O field objects for monitoring and editing PID tuning parameter value. Necessary I/O field objects have been added in this screen. Now we have to link these I/O field objects with the tags for tuning parameters. Finally, we have come to finish our SCADA interface with this final look. This SCADA project has been developed to perform PID operation for a real-time temperature control. During PID operation, this SCADA interface allows operators to monitor PID parameters and adjust target settings as well as tuning parameters. For graphical display of PID operational parameters, a trend view object has been added in a different page in this SCADA project. From the project tree, open the page for Trend View. This is the Trend View object, where there will be graphical display for the operational parameter set value, process value, and the manipulated value. Now we are going to run this SCADA program and perform real-time PID operation for temperature control.
Click on the Runtime button from the toolbar to load the SCADA project on this PC. The SCADA project is now running on this PC, and this HMI interface is now getting the PID data from the PLC. This moment, the PID program is now in the state of disable mode. So click on the Enable button to start the PID operation. Now navigate to PID parameter set value and set a target value for this controller. Note that the controller has set its output to 100% and the heater is turned on. The chamber outlet air temperature is rising now, that is visible in the controller parameter process value. The chamber outlet air temperature is also visible from temperature meter located at the outlet path of the heating chamber. Open the page for trend view. In this trend view, we are getting the graphical visualization for PID operational parameters, set value, process value, and controller output value. Now go back to main page and continue to observe the PID parameters value. Note that the process value, or chamber outlet air temperature, has reached to the controller's set value and it is remaining in stable condition. Open the trend view. Note that the process value is getting closer to the set value. Now change the target value and observe the process response. Note that the chamber outlet air temperature has started to decrease. Again, the chamber outlet air temperature, or process value, nearly reached to the new set value. We have reached almost at the end of this video. I think this video will be helpful for you to get an idea about how to develop SCADA project for S7-1200 PID Compact program and perform SCADA-based real-time PID operation for temperature process using TIA portal software. If you find this video helpful for you, please like, share, and make comments on this video, and don't forget to subscribe this channel.